Have you ever really thought about light? It's everywhere, instantly illuminating our world. But have you ever stopped to consider just how fast it actually travels? We experience it as instantaneous, but light, believe it or not, has a finite speed. It's the ultimate cosmic speed limit, a fundamental constant of the universe. So, what is the speed of light? In a vacuum, it's precisely 299,792,458 meters per second. That's about 186,282 miles per second. To put that in perspective, a beam of light could travel around the Earth's equator over 7 times in a single second. For centuries, people debated whether light traveled instantaneously or if it had a measurable speed. It seemed too fast to ever pin down. Early scientists like Galileo tried to measure it by having 2 people flash lanterns from a distance, but it was far too quick for human reaction times. The first successful measurement came from Danish astronomer Ole Romer in the 173 century by observing Jupiter's moon Io. He noticed slight delays in Io's eclipses as Earth moved closer or further from Jupiter, realizing it was due to the varying distance light had to travel. This was groundbreaking. It proved light had a speed, and it was incredibly fast, even if his exact number was a bit off. Later, scientists like Fizeau and Michelson used ingenious terrestrial experiments with spinning gears and mirrors to get even more precise measurements. But why is this speed so fundamental? It's not just a speed. It's a cosmic constant, a universal speed limit that nothing with mass can ever reach. According to Einstein's theory of special relativity, as an object with mass approaches the speed of light, its mass increases infinitely, and time slows down for it. This means only massless particles, like photons, the particles of light, can travel at this incredible speed. It's a profound idea. The speed of light isn't just a number, it's woven into the very fabric of space-time. Okay, so it's fast, but how does this mind-boggling speed affect your everyday life? Let's look at some examples. Think about a thunderstorm. You see the lightning flash almost instantly, but the thunderclap takes a few seconds to reach you. That's because light travels about 1,000,000 times faster than sound. The light from the lightning arrives almost immediately, while the sound waves take their time. This difference allows you to estimate how far away a storm is by counting the seconds between the flash and the boom. Or consider GPS. Your phone knows exactly where you are, thanks to signals from satellites orbiting Earth. These satellites send out radio waves, which are a form of electromagnetic radiation, just like visible light, traveling at the speed of light. Your phone measures the tiny differences in arrival times of these signals from multiple satellites. By calculating how long it took each signal to reach you, and knowing the speed of light, your phone can pinpoint your location with incredible accuracy. Without the constant and known speed of light, our modern navigation systems simply wouldn't work. Now for something truly mind-bending. Looking at distant stars. When you gaze up at the night sky, you're essentially looking into the past. The light from stars millions of light years away has taken millions of years to reach your eyes. If a star is 100 light years away, the light you see tonight left that star a century ago. You're seeing it as it was then, not as it is now. It's like a cosmic time machine. This incredible delay helps astronomers study the history of the universe. Even closer to home, the sun's light takes about 8 minutes and 20 seconds to reach Earth. So, if the sun were to suddenly disappear, we wouldn't know about it for over 8 minutes. The last light would still be on its way. The speed of light isn't just a scientific curiosity. It's a practical limit that defines our perception of time and distance in the cosmos. From communication to cosmology, the speed of light is central to understanding our place in the universe. So, the next time you flip on a light switch or glance at the stars, remember the incredible journey those photons are making. Light isn't just fast. It's a fundamental constant that underpins physics, allows our technology to work, and literally lets us see into the past. It's a constant reminder of the mind-bending wonders of our universe, always traveling at its ultimate unyielding speed. Keep exploring, keep questioning, and keep shining bright. See you next time, Science Sketchers.